So my name's Gay Sheffield, and welcome to Straight Science. Straight Science is a evening seminar series put on by University of Alaska Fairbanks Northwest Campus. So you're here, right here, and also University of Alaska Fairbanks Alaska Sea Grant. So both Northwest Campus and Alaska Sea Grant, we are public servants of the Bering Strait region, which is the homeland and waters of the Inupiaq, St. Lawrence Island Yupik, and Central Yupik peoples. So you guys are all in for a treat. Everyone online already knows they're in for a treat. Mitch knows he's in for a treat. And we have Rick Thoman. So Rick Thoman is no just regular speaker to us. He made a grand entrance, actually. Well, earlier this week, we had a really big low system that came through, which you'll hear a little bit about tonight as well. Rick has been not only here in the 70s when he was working for the National Weather Service, he's returned in his new position with the University of Alaska Fairbanks Alaska Climate Assessment and Policy, ACAP, UAF, ACAP. And I think more so because we just had this really bad storm, and it was a big one, and we feel really bad for Kotzebue and for Shishmaref and everyone in the Chukchi Sea that has sustained incredible damage of property and flooding events that are going on right now. So it's a little, we were very blessed down here. Kotzebue and Shishmaref and the Chukchi Sea took it on the nose, and they're having big problems right now. So, but it was sort of, I'm not surprised. All of a sudden we have this horrific thing. Everyone's wondering, wait, what's happening? And people were turning to Rick Thoman. Yes, you can turn to the National Weather Service as well, but for the Bering Strait region, with all the public service that Rick Thoman has done since he has, I don't know, 2017, 2016, we're coming back with your new position.
Well, I think my very first Straight Science was even before that, in 2017, when I was still with the Weather Service.
Oh, yes, it was. Actually, it was when you were with the Weather Service. And through it all, and we have been experiencing massive environmental, ecological, industrial, and now geopolitical changes in our maritime situation since the last 10 years. It has been phenomenal, and Rick Thoman has come back again and again and again, provides this region updates, Facebook page, on the newspaper column news every week, and has really guided us and has been a resource and a service to this region that has been unparalleled from afar. And so with that, there's no better person to tell us about what has happened out in the region, what just happened, and also what will happen with the best outlook. So thank you all for coming, and thank you all online. And we will let him take it away. Rick, we're so glad you're here.
All right. Thanks very much, Gay, and hopefully all the technical difficulties are ironed out, but
I hope so.
If they're not, they will be, right? So yeah, thanks for the introduction, Gay. So Western Alaska, a very special place to me. I started my weather service career right here in Nome, back in the pre-automated days when they hired new people and we were chief weather observers. But unfortunately, the Weather Service didn't count on me falling in love with Nome. This is a wonderful region, wonderful people, most spectacular people and landscape, seascape, you'll find anywhere. So it's been a pleasure to work in this region. I've been doing this work for more than 40 years, and there's a reason I keep coming back. It's because I love it. So
thank you for that. It's a good region.
Yeah. So the original impetus here was Western Alaska had a fairly I'll use the salty language of crappy summer, or at least that's what it seemed like. And that's in stark contrast to a lot of the Arctic that had, once again, a very warm summer, not quite as warm as summer of 2023. So that, you know, people here, of course, are very well aware of the weather. And what's this context that the Bering Strait region has been cool and had a stormy summer, while a lot of the Arctic is once again cooking. So that was the impetus. And then, of course, we got the bonus October storm this past weekend. And if you're not from here, you may not know, the weekend before, Nome and many places in the eastern Bering Sea recorded their lowest sea level observations on record. And there's pictures from the weekend of October 12th, people standing where there should have been ocean water. Some very nice pictures. So big dramatic things happening just in the last 2 weeks here in the region. Let's jump right in. Here's what I thought we'd talk about tonight. Well, just since I started off doing the summer, that's a little bit focus. So temperatures, rain, storminess. Think of storminess more as an autumn thing in the Bering Sea, but we had plenty of it in the summer. Sea ice, some interesting stuff going on with that, and the sea surface temperatures. And then I want to put that in what's happened here into that Arctic context. As we usually do in these this time of year, I like to come to Nome this time of year because the winter is coming up and everybody wants to know what's going to happen with the sea ice, because that's so incredibly important to the region. So I like to come this time of year, and that means I have to do the winter outlook. So that was going to be my ending, but you get the bonus slide on the wild weather we've had just in the last few weeks. So starting off here, summer temperatures in Nome. So the graphic is just a departure from normal for Nome Airport every day from June 1st to the end of August. And you don't need any statistical analysis to just look at that and see really a tale of two summers, temperature-wise. June, yeah, some warm days, some cool days. Looks like kind of the way it typically goes. But turn the calendar to July, and whoa, 51 of the 62 days in July and August were cooler than normal. June was actually almost 2 degrees Fahrenheit above normal for Nome, but the rest of the summer knocked that right out. So very two different faces temperature-wise for Nome. Now here's what it looks like regionally. Now we were just looking at the weather climate observations from the airport. This is from a climate reanalysis model. The big black dot is on Nome. You can see the other places identified there, and this is broken out by month. So in June, you can see the color band here is 1 degree Fahrenheit. White space is within 1 degree of normal. You can see June warm over much of interior and western Alaska, about as far west as Nome, down into the YK Delta, up into northwest Arctic Borough. Notice below normal temperatures through the Bering Strait, St. Lawrence Island, and really cold on the Chukotka side of the Bering Strait. Moving to June, we pretty much lose, except over the waters, much of any areas that were warmer than normal. The departure's not as great in Chukotka, but really pretty cool most places, and even worse for western Alaska if you want warm weather in August, where quite cool again. Different though up on the North Slope from June, where Utqiagvik and points east were pretty warm during August. So again, this is reinforcing that the tale of two summers, temperature-wise, not just in Nome, but really all across western Alaska. Now, I do want to highlight what's happened to our west here. This is a time series plot from the climate reanalysis model. On your left is the summer average temperature for St. Lawrence Island, and on the right is for the Bering Strait coast, not just the Alaska side of the Bering Strait, but our neighbors in eastern Chukotka. St. Lawrence Island, June, July, August average temperature, coolest since 2008. And there's been a run here of 4 summers in a row, significantly cooler than normal. But look in the Bering Strait coast, that is really remarkable. The coldest summer in this data set since the 1960s. That is really a phenomenal departure there. You can see again, there's been 4 in a row that have been quite cool, quite below the linear regression trend line. So just think of that as the moving average, a time varying average, but really quite a cold summer for the Bering Strait. And folks at Diomede, of course, snowed multiple times during the summer and even saw some sea ice during August. So it really was a throwback to the past in the Bering Strait. So we did have some warm weather. I know that's not, no mites, you don't want to hear that, but it really was, right? Actually, lots of people were remarking during June. It was quite a nice month, lots of, certainly no less than normal sunshine. And of course, at the longest days of the year, Nome Airport did set one record high during the summer. That was on June 10th, 77 degrees. And because Nome has one of the longest climate records of any place in the state, we have almost, not quite, but almost unbroken observations since late 1906. Breaking a daily record, in this case by 3 degrees, is a non-trivial occurrence. There were actually 7 days during the summer with highs in the 70s. That's very close to normal, if you want to get technical. It's 1 day more than usual. Did it feel like that? On the contrast, there were 17 days with highs in the 40s. Again, that's very close to the normal, but the distribution was not. Typically, in the summer, you would have most of your days in the 40s would occur during June when the ocean temperatures are still low. This year, there were actually more days in the 40s in July and August put together than there were in June. So the bulk statistics, it looks like a pretty normal summer, but that distribution through time, how we live, right, day to day, that was not normal. I do want to point out too, remember in that time series of Nome, there was a few days in the second half of July that got real warm. And out at Gamble, northeast tip of St. Lawrence Island, the Marine Exchange weather station got to 69 degrees on the 22nd. That probably doesn't sound very warm to you, but for Gamble, personal weather stations, folks home reporting temperatures in the low 70s, that is, according to the elders, they don't remember ever seeing temperatures that warm there. And that was a result of very warm air that came across from the Russian far northeast and really boosted the temperatures. There's not much of an offshore wind direction at Gamble, but they got it and pushed the temperature up to almost 70 degrees, really quite remarkable. Here's the one of the really interesting things about Nome. If you're not from Nome, this might be news to Nomites. This is a known and appreciated feature of the climate. That in this early summer, there's often this very strong difference in the temperature between the coast and just a few miles inland. Happily, this day and age, we have lots of personal weather stations here in the Nome area, and you can see there about a little after 3 o'clock on June 9th, it's 47 degrees out on the jetty at the port, and you get just a few miles inland there, and temperatures were up into the 70s. Really very nice early June day. So yes, there really was some warm weather this summer in Western Alaska. There was also some rain. One might say a lot of rain, but again, the summer with two faces. June had way below normal rain. June is typically a fairly dry month, but even for a dry month, there was less than normal. In fact, it was the lowest rainfall in June in more than 20 years. On the other hand, well, again, we turned the calendar, and we had a series of storms, especially in the first half of July, that really pushed the rain total up. We got up above normal. That's the thick black line, and we never looked back. Overall, July was the 5th warmest, again, since late 1906. Fifth highest, and August wound up with the 7th highest rainfall. Overall, for the whole summer, this was the 3rd highest rainfall in that 117-year climate record. But for July and August, it was by far the highest rainfall in the two late summer months. Really quite remarkable. For NOAA in the room, last summer also we thought was rainy, and you can see, yeah, it was above normal, but it didn't hold a candle to what we had this year. Here's a regional look at precipitation. Again, look at the difference between June and everything else. This is the percent of normal precipitation. And June everywhere in Western Alaska, less rain than normal. And July and especially August, way above normal. Not just here, not just the Seward Peninsula, from the Bristol Bay all the way up to Northwest Arctic Borough and on to the North Slope. Really quite a remarkable precipitation pattern that we saw this summer across the region. So the July rain was really interesting in the sense that first half July was a true soaker. 5.5 inches of rain the first half of July. The previous highest rainfall the first half of July was 3.5. Again, 117 years of records, obliterated the previous record. A lot of that came in one storm. Mostly July 2nd and 3rd, lingered on into the 4th. And you can see, hopefully, maybe if you're in the front row or you have better eyes than me, there's some rainfall totals here of 3 to almost 4 inches of rain for this event, just inland from Nome, or just inland from the city to the north of town. Really, and that is the highest single storm rain event since August of 2019, which was produced the highest 24-hour rainfall of record in Nome. So really, that was a big deal. Turn to the second half of July, was pretty cloudy still, but it didn't rain much. In fact, less than half of normal rainfall the second half of July, and the second lowest in the past 10 years. Again, was still pretty cloudy, but was not even nearly as wet as the first half. It wasn't even close to normal for July. So that kind of very sharp change in the weather pattern that we saw July to August also played out with precipitation during the month of July. So then we turn to August, and we had thought it had been rainy, and it had been. But the storm season really cranked up early. So this is a view from the image there is from a NOAA geostationary satellite. This is from August 19th. Ex-typhoon Amphil had just crossed from the North Pacific into the southwest Bering Sea. You can see at that point it was still a long way from Nome. But this was coming on the heels of 2 other storms that really pounded southwest Alaska, particularly the Kuskokwim coast and the lower Kuskokwim River produced severe flooding in those areas, 16th and 19th. And then the northern Bering Sea got hit hard by ex-typhoon Amphil on the 20th and 21st. So one of the things I get asked about most is storms and storm tracks. And so we had this incredibly stormy August. This is my effort to try to give the people what they want. So this is a plot of all the storms actually in June and July, and each storm gets its own color dot there. And without some context, is this a lot or a little? This is a lot. We don't have a database of this kind of stuff as much as I would like one very much, but we don't have that at hand yet. But I do want to point out, one, you can see a whole bunch of storm tracks. They're all moving from southwest to northeast there. I do want to point out the storm that brought all the rain in early July, biggest rainstorm since in 5 years. And that's this one way up here. The center of this low never got east of Wrangel Island and yet produced all this rain way far southeast. If that sounds vaguely familiar, if you've been paying attention to the weather in the last week, that's very similar to the track, or at least part of the track of the storm that brought the flooding, the terrible flooding to our north and some flooding down here. Very far west location of the center. Most of the other storms are more what we would expect for the Bering Sea, based somewhere in the Bering Sea. Unlike July, it was pretty rainy all of August. In fact, some rain every one of the first 23 days. Some of those days didn't have much rain, but every day had some, the first through the 23rd. High temperature for the entire month of August in Nome, only 58 degrees. Only two Augusts in 117 years have had a cooler low temperature in August. Amphill actually did not produce a lot of rain in the region. What it produced is a lot of wind. Here in Nome, the average wind speed on the 21st was just under 30 miles an hour. It's actually the highest average daily wind speed during a summer month, going back into the 50s. That's as far back as I have good hourly wind data for Nome. Windiest summer day. Now, what's interesting is there's one other place in Western Alaska that we have multi-decade wind data, and that's Bethel. And Bethel also set their record for the windiest summer day on with a different storm. It was a storm on the 19th. So a lot of high energy in the Bering Sea this summer with all these storms. Really quite, I mean, we were remarking at the time, it's more like October storm. Temperatures weren't like October, but this storm after storm after storm was very reminiscent of now. For folks in Western Alaska, one of the most common remarks this summer, one, it rained a lot. It's also incredibly cloudy. And this is a graphic from our climate analysis model that shows that. So this is using our standard 30-year baseline for climate analysis. This is how the cloudiness for, this is for July and August ranked. And that darkest gray there, almost black, that includes Nome. Those are areas where there was less sunshine than any other July, August in our 30-year reference period. And all of the Seward Peninsula and Bering Strait there are either in the lowest sunshine or the second lowest relative to that 30-year baseline period. And I'm going to guess that there's probably no one in the region which would take too much issue with that. Notice too, nearly all of Alaska was pretty cloudy, or at least less sunshine than, way less sunshine than we would expect for July and August. So yes, gray in Western Alaska, but happily shared the wealth with the rest of us. Back in the dim times before the pandemic, Western Alaska suffered through several summers of extremely high sea surface temperatures. Some of you will recall the blob years in the Gulf of Alaska from 2014, 15. This year, as you can see in the Bering Sea, very different story. Basically, the entire Bering Sea for the 3-month average, significantly colder than the 30-year average, really quite remarkable. And so the obvious question is why? And you might have already guessed the answer. So we haven't gotten to sea ice yet, but we will momentarily. We didn't have a late melt of the ice this year, but it wasn't early. There was still significant ice in the northern Bering Sea, scattered around as it always is when ice breaks up in the spring. So patches of ice persisted into mid-June. That's not terribly unusual, but so some of that heating during what turned out to be the sunny, warm part of the summer was going into melting that ice and not warming the water. And then we turned the calendar to July, and we saw very, very cloudy, and particularly during August with all of these storms, started in July, but really cranked up in August. Just constant mixing of the ocean surface water. And so there was no chance for any kind of layer of warm water to develop at the surface like we often have. And as a result, we see almost everywhere in the eastern Bering Sea below normal sea surface temperature. Now, my guess is when you first looked at that, so that's actually not what you saw. You saw the deep blue there off the Chukotka coast. And
there is a comment in the chat. People are very interested to know, especially on that storm track one. You're using your hands, and the online crowd would like you to use a cursor or some such thing like your mouse. Just some feedback there from the folks. Thank you, online.
Thank you. Thanks for the reminder. Was there something on the storm tracks you would like me to point at? Oh, one of the things was, right, the storm in early July.
There you go. I think that probably is
Is that the one? Can you see that online? Yep, I bet you can. I hope you can.
Yes, you can.
All right, so this is the storm. This produced all the very heavy rain, highest rain in 5 years in Nome. And this storm track that stayed west of Wrangel Island. Part of this very far west track is very close to what we saw with the most recent storm. It was not a classic Bering Sea storm, as we'll see, but took this very far west track. But even with that, it was a big storm, lots of south flow to the east of it. So Nome really got a lot of rain out of that. And again, I apologize for not using my mouse. It's so nice to talk to people. I forgot there's people online. Sorry.
I forgot too.
All right, so sea ice. Here's how it looked through the summer. So June 1st, you can see there's still some ice there in the northern Bering Sea. Not unusual. We haven't had that much ice every June in the last decade, but not even by the 21st century standards. That's not a lot of ice. The Bering Sea had mostly cleared of ice by late June, but it was relatively slow to clear, both in the southern Chukchi Sea and the Alaska portion of the Beaufort Sea. Although you can see there, the Beaufort Sea by the end of August was clearing nicely in the Weather Service Alaska region concentration analysis here. But notice this tongue of high concentration ice there off of the northeast Chukotka coast. And starting in mid-July, we had pieces of that ice got caught up in the East Siberian coastal current and worked their way south along the west side of the Bering Strait. And this continued from mid-July actually into early September when it ended. And I mentioned that in August, Diomede actually got saw a couple days with the sea ice. And that was actually ice. It didn't come down from the north. It had moved down along the west side of the Bering Strait, and then one of the August storms, strong south winds actually picked up that ice and moved it a little bit east, and so blew that some chunks of ice through between the Diomedes. So it's August. They've got some ice, and they got roaring south winds. Not what you would expect in the 2024, but that's what got delivered. Should say about that Chukotka ice too. Very interesting. That ice lasted, well, maybe it's still there, but it lasted at least into early October. That's actually the first time we have had ice that far east on the Russian coast in mid-September since 1998. So historically, in the 90s and before, this would not be news. It's news because things have changed so much. So rare, unprecedented for the 21st century, boringly common in the 20th. So here, I wanted to show this for a couple reasons. One, we had the Northwest Passage through the Canadian Arctic Islands, connecting the Atlantic to the Bering Strait. Was opened very early, and I'm sure a record high number of vessels transited the Northwest Passage. including we saw here in Nome, a whole slug of sailboats in the harbor in June, end of September, right? Any rate, they'd come from the Atlantic, flotilla of sailboats, really quite remarkable. And notice here on the left-hand side, this was the typical ice extent map on the day of the Arctic minimum in the first 11 years of the satellite era. So we've got ice touching the Beaufort Sea coast in Alaska. The Wrangel Island westward there was typically ice to the coast on the day of the minimum, and compare that to what we had this year. I wanted to show this one. Look how far north the ice has retreated this year. And I wanted to show this not just for that, but it puts this perspective of this little area of ice on the North Chukotka coast into perspective. Regionally, it was important, absolutely. But it does not mean that, oh, Arctic sea ice has recovered, all's better. It's a little tiny chunk. Yes, we're happy to get it now, but this does not, we can't use this to forecast, no ice, and the ice is coming back. No, record low, or a second lowest sea ice extent in September in the Beaufort Sea. Chukchi Sea was not quite as low, thanks in part to that comparatively small patch of ice that persisted all summer. Here's some satellite pictures of this ice. This is a false color satellite imagery from, I got this from the folks at GINA at UAF. So the turquoise blue here is ice. The white stuff is clouds. I've annotated this for your viewing pleasure. So here we are at the end of August. You can see right there's little Diomede. There's big Diomede, and we've got ice here on the west side of the Bering Strait. This is about as far south as most of the ice got. We had a little, I think there was one push that got down into here, but that was about it. Here's the view 3 weeks later. There was still a little bit of ice on the west side of the Bering Strait, but you can see the ice was starting to pull back here a little bit here by the third week of September, but was this continuous band. So who's going to ask the question? Why did that ice stay? Okay, why did that ice stay? So this is really interesting. So here's what it looks like. This is an area that it was clear last spring that thick ice was building up there. As we proceeded through the summer, it became clear, not from this kind of imagery, but other imagery, that the ice that was hanging on was dirty ice. It had sediment from the bottom on it. So what looks like happened is that ice was continually rafted up there during the late spring. There was a lot of north wind, so we had basically ice on top of ice, pushing that all the way down to the shallow ocean bottom there in the western Chukchi Sea. And then, of course, that all froze together in this big frozen mass. And so that took a very long time to melt out, and not all of it did. So a very interesting situation, but again, it's probably not something that we could expect to be repeatable. It doesn't mean it won't happen again, but it's not a sign of anything in the large scheme of things in the Arctic climate. So that's the why of the ice. How about the why of the weather? So the meteorologist in me wants to, whatever's happened at the ground, look up. Always look up. And so what we have here on your left, this is the middle of the atmosphere. This is the average high and lows in the middle of the atmosphere. You can think of this as the steering level of the atmosphere. So in June, we had high pressure over eastern interior Alaska, and that means over the black dot, which is Nome. We had winds at mid-levels of the atmosphere are out of the southeast. That's a good way to get warm in Alaska in the summertime. But look what happened by the time we got to August. That high is long gone, replaced by a very cold low up in the high Arctic with this area of low pressure extending south just west of the Bering Strait and this southwest flow off across the Seward Peninsula and Nome. So it was cool and southwest flow. Sounds like rain to me. Rain and cool, and that's of course exactly what happened. Now these are the monthly averages. There's of course lots of variability in there, but these do offer a reasonable explanation of basically really the big flip that we saw in the weather pattern. All right, now let's put it all in context. So we're looking down at the North Pole here, and the black line is 60 degrees north, and I've labeled Nome on there for you. And so on the right is the average temperature departure from the 1991 to 2020 baseline, our standard international baseline, from this climate reanalysis model, and 2023 on your left, and this year on your right. So actually the patterns are pretty similar, aren't they? We've got cool, at least in the Bering Strait in 2023 and in 2024, cool here in the Eastern Canadian Arctic, warm across a large chunk of the Eurasian Arctic. Greenland more dramatic in 2023, but the pattern is similar. One area that was quite different was Iceland, with relatively warm in 2023, but very chilly and rainy, just like Alaska, in 2024. So very different for that comparatively small area, but patterns look kind of the same. Overall, last year, which was almost the warmest year of summer record in the Arctic, 82% of the Arctic was warmer than normal. This year we dropped down a little bit, but still quite, the Arctic was warm. Western Alaska was not. Bering Strait really was not. Oh, so does this mean in a warming Arctic that the Bering Strait region, Western Alaska, is going to be cool even as other folks warm up? And probably not. So the warmest summer of record in the Arctic so far is actually 2016. And in 2016, of course, was one of the very hot summers, not just in Western Alaska, over most of the state. The cool area in 2016 was here in Siberia. Chukotka, extremely warm. Alaska, extremely warm. Eastern Canada, extremely warm. This is what this area here in Western Siberia into the Eastern European Arctic really drove the temperatures up. But just the departures of below normal versus above normal areas very different in the warmest year than in the almost or one of the warmest years. So I think I'm pretty confident in chalking up the last couple of cool rainy summers around the Arctic or around our region here in Western Alaska in the Bering Strait region. We just kind of drew an inside straight 2 years in a row. Probably not going to be repeatable with any predictability. Okay, that's our wild and wacky summer. So now we'll transition to our outlook. And one of the things that I do at ACAP, I do a monthly climate outlook webinar every month for 10 years now. And we rely heavily on NOAA's Climate Prediction Center, College Park, Maryland, who is the primary NOAA organization responsible for forecasts for about 2 weeks in the future on out to about a year. So you may have heard we have a developing La Nina this year. We had El Nino last year. So it's been slow to develop, slower than initially forecast, but we're still pretty confident that we're going to get a La Nina this year. Okay, can we use this? Well, we have some confidence in. Can we use this to make a forecast for the coming season for Western Alaska? So what I've done here is for the 17 La Ninas since 1976-77, I've asked, were they warmer or wetter than normal? Just what's the percentage of those 17 La Nina seasons that were either warmer, temperatures on the left, or wetter on the right? And temperature-wise, there's really nothing beyond a coin toss there. Knowing that it's La Nina does not help us with in this case, the November, December, January average temperature. About half the time it's been warmer than normal, half the time it's been cooler than normal. Precipitation, on the other hand, on the right-hand side, over most of Alaska, except for western Alaska and southeast, has fairly notably tilted to the dry side, so less than normal precipitation. Precipitation, of course, rain plus the water equivalent of melted snow. So just based on the fact that it's El Nino for the early winter season here for western Alaska, great, it's La Nina. How's that help? Doesn't help. Can't really, there's nothing in the most recent 17 La Ninas that would help us to tilt the odds, because what's occurred is just in the coin flip. How about sea ice, which is really what folks, a lot of folks in western Alaska really care about. When's the ice coming back? Because it controls so much, controls shipping, controls hunting. Really, we would really like to get a handle on this. So the Climate Prediction Center does produce every month an experimental seasonal outlook, and one of the products they produce from that, there's 20 different model simulations, and so it's not just one, so we got 20 of them. And one of the products they produce here, which I am showing you, is when does the first significant ice occur? So sea ice concentration get better than 15%, so not open water. And this is supposed to be the first date. It could go away, but the first date. So this is the latest forecast. It was produced in late September, and the color bar there is on the bottom. I've labeled some of these just for your ease of interpretation. And on the right-hand side is the National Weather Service sea ice concentration as of yesterday. Well, I'm pretty sure there's going to be problems with this forecast. You can see here in the Beaufort Sea, nearly, not quite, but nearly all of the Beaufort Sea here was forecast to have first ice by late October. I'm guessing that is not going to work out. Maybe a better forecast here in the Chukchi Sea, late November, of course, is this area offshore is always the last to freeze up, both in the old days and the new days. This is pretty typical for recent years, late November. There's some other big busts. There's been no appreciable ice in Kotzebue Sound yet, much less in early October. There was a little bit of ice in Norton Bay. A lot of that, or all of that's gotten flushed out. But this experimental sea ice model is not really designed to handle these kind of small indentations. It's really designed to get a handle on, the open ocean ice. So I don't count these against it. This is a big miss, though. This is a big miss. Whether we'll really see ice all the way to St. Matthew Island by late January and the Pribilofs in early February remains to be seen. This model does tend to develop too much ice along the southern edge here. But one of the great things about this, because it's experimental, that means it's not fixed, and the Climate Prediction Center is actively working on this model, and we've seen significant improvements in the about 5 or 6 years that they've been running this. So kudos to the Climate Prediction Center for working to improve this, because this is so important for northern and western Alaska. I do also want to point out on the sea ice concentration analysis from yesterday, that old ice there, this is the least amount, lowest concentration of ice in this area all summer long, and it's not summer. So technically at this point, we are melting second year ice in the third week of October, which is pretty remarkable. Obviously, some of this stuff is going to survive, but at least for the southern portions of the Arctic, maybe October 1 is not a good cutoff for the end of the melt season anymore. All right, turning to the Climate Prediction Center's seasonal outlooks. For November, December, January. Am I the only one that can't believe it's 2025? Here's the outlooks for the early winter season. Black dot is Nome. The colors here, remember, Climate Prediction Center does 3 categories of forecast. Significantly above normal, significantly below normal, and near normal. And like all good climate forecasts, they're probabilistic. That means we're going to tell you the chances of all of them. So very different than the weather forecast on your phone. So for Western Alaska for the early winter season, Nome, St. Lawrence, most of St. Lawrence Island, Bering Strait has just a very slight tilt. The experts favor significantly above normal temperatures for the 3 months as a whole. Stronger tilt there across the North Slope, especially the northwest slope there, where the odds actually are above 50% for significantly above normal. Large chunk of no tilt to the odds. So 33% chance that it'll be warmer than normal, 33% chance it'll be near normal, 33% chance below normal. That's the default forecast. Precipitation, on the other hand, Western Alaska, according to the experts, about twice the chance of significantly above normal precipitation than significantly below. Just what we want, right? Nome, if it doesn't rain or snow, another drop or flake the rest of the year, this is already a top 10 wettest year in Nome. If this forecast works out, then we do have significantly above normal precipitation. Unless it all comes in January, 2024 is going to definitely move up in the precipitation ranks. And for the midwinter season, not very much different for Western Alaska by the experts. For Nome, Teller, Brevig on up to Shishmaref, still in that just a slight tilt to favor significantly above normal. For the Bering Strait and Gamble, Savunga, St. Lawrence Island, they actually have twice as likely to be significantly warmer than normal than significantly below normal. Precipitation looks just like the early winter season, double the chance for above normal than significantly below normal. If the experts' forecasts are what we call if they're not biased, because these are probabilistic forecasts. There's some chance any of the 3 categories could verify, but if they're not biased, then our wet weather will persist. Bonus slide, and this is it. I know this is hard to see. The red dot is Nome, but I wanted to show this because I think it's really important. This is just a standard weather map of highs and lows and fronts. This is from Environment Canada, which provides this very nice Arctic-centric view. And I can't, unfortunately, in this version of PowerPoint, apparently we can't make this GIF stop. Sorry. Some other version of PowerPoint we could, but for this storm tracked very far west. It was very well handled by the models, came up the west side of the Kamchatka Peninsula, and then on into either the westernmost part of Chukotka or the easternmost part of the Sakha Republic. But notice south of the Aleutians, there's this big giant high. And that's why the pressure difference between this very deep storm, very far northwest, and big high pressure over the North Pacific allowed so much impact so far away from the low center. If you told me, okay, Rick, quiz time. I'm going to tell you on October 21st, we're going to have a storm. It's going to produce 58-mile-an-hour winds gusts in Nome. It's going to produce coastal flooding at Kotlik, at Scammon Bay. Going to be flooding at Gullivan. Tell me the track of that storm, Rick. I would never, ever say, oh, it's going to go up through the Russian far northeast and the low center is never going to come within 700 miles of any point in Alaska. I would never say that. But reality comes to the fore. Really, really remarkable. So we did have some erosion out the council road here from the flooding. Some camps were damaged. One interesting little factoid, Nome had 3 days in a row with peak winds of over 50 miles an hour. That is uncommon. Actually, we have to go back to February 2022 for the last time Nome had 3 days in a row with 50-mile-an-hour winds, and those were east winds. Of course, the worst flooding from this was north of the Bering Strait, Shishmaref and Kotzebue, very severely damaged. I presume that the world, have folks out getting some of the details on the storm. Elders in Kotzebue saying they have never seen this much water in town before. Shishmaref lost an old graveyard, gone. Just the photographs on social media, it's just a debris field. It looks really, really terrible at Shish. High water farther north as well. So really quite an impactful storm. And this is one that we're going to want to dive into this because of this very unusual storm track. This is not just another Bering Sea storm. In some sense, it's not a Bering Sea storm at all. It's a Chukotka storm. And we have to, is this another way? Just like Burbach was one more way that we didn't used to have to get flooding in this region. Is this something new? Is this just a chance event that we'll probably never see again? It's worth some detailed, a deep dive on this to really understand what happened. All of this is occurring, as I mentioned to start, just a week, 8 days, 9 days after the lowest ocean levels on record. Not just in Nome, where it's one of the very few places with actually a long multi-decade ocean level in Western Alaska, but lots of people reporting all along the Bering Sea coast north of Nunivak Island, some of the lowest water they have ever seen. And that was a result of strong north winds blowing the entire length of the eastern Bering Sea coast, from the Bering Strait all the way down to Unalaska. And there was no ice, so there was nothing to impede the plow of water as it moved south. So really quite the remarkable flip. So the total range in just 11 days in Nome was 14 feet. For a place that the average tidal range is about less than 2 feet, that's really quite remarkable. So that is what I have for you today. I'll plug our Facebook group, Seward Peninsula, Bering Strait Weather and Climate Info. It's exactly what it says. That's a place that we share weather and climate info, and that's what's on there. By group preference, it is a closed group, but we will approve anybody that has any interest in the region. I do want to give a special thanks to Gay, who's been driving the Straight Science series for a long time now, and for Northwest Campus here for hosting it. So quite enough.
Because I could never just stop right here. So this is Gay, and before we get to questions, and I see you, Wes, this is the time to give some love to our speaker, Rick Thoman, on the chat. So the Straight Science audience is always good. It is never easy being a public speaker, never is. And thank you very much, Rick, and awesome job. So this is a time while you're thinking of your questions, throw a little love to the speaker. And I do want to just read, and I see you, Wes. And Wes, actually, before you even started, or you were just starting, and he wrote, even before the talk, thank you, Rick, for all the info you have provided us over the years. So that was even before the talk. And also on a thread that is in a private thread, It just says, really engage with the topic. We're all waiting for him to say the actual date for the end of the world. So that was a good one. And there's lots of things. So with that, while everyone's thinking of their questions, Wes, go ahead. Hopefully
Can you hear me?
we can.
Yeah. So, Rick, it's interesting that you mentioned about the extremely low water, because here in Unalakleet, the traditional knowledge, traditional talk is, or comments are, as soon as we had that extremely low water a week and a half ago, is immediately the elders are saying, and people that have been around a long time, we're going to have a flood event. A flood event is going to happen. And
Wow.
be it wasn't as big as Murbach. It was, I mean, where you're still talking, it was one of the top flood events here in Unalakleet in, the top 5 probably in the last 20 or 30 years. So but that's a very common thing that I hear here is when you have if you see extreme water, that everybody expects that we're going to have a really high water event, not in short order of, a couple weeks kind of deal. So.
Well, great. Thanks very much, Wes. That's really interesting to learn. So thanks for sharing that. Thanks for your kind words. But I sense that we have a research topic has been presented to us. Because here's the deal. The elders say it, take it seriously.
Yeah. All right. Any iPhone to everyone. Oh, you're sending a picture. Well, let's see if we can get the chat back up. Or they're sending pictures. Oh, thank you, Snake River. On October. Let's get rid of that. And then if I go like this, I get to that's what we want right there. And the chat.
I think if you click green, maybe
This right here?
the green at the very top.
Top center of the screen.
Right?
Yeah.
Chat. There we go. Thanks. And there's some pictures here that just been sent. Snake River. All right, they're loaded on mine, but there we go. Thank you for sharing. We'll open them up. Oh no. No, we won't. But
You
will
put on the
get
photos. You should open.
those photos.
Yep.
I'm glad we're with all these techno savvy peeps.
Maybe.
Okay, well, that's there you go. So Snake River. I don't know about the AI.
And some puppies.
Oh yeah, look at that. Wow, Snake River.
Wow.
So Snake River, this is the cursor. This is the Nome Airport right here. So when you came in, look at that. Wow.
So this is from October 12th?
12th. It says 12 and 21.
Wow.
iPhone.
Same spot.
Oh yeah, the flood and yeah. This is the jack-up rig.
No, we still don't want it. Sorry. No.
No, we don't want that either. So yeah, look at that, before high water and low water in the same week. So thank you very much, iPhone.
So if you're a member of our Facebook group or join here, folks shared a lot of pictures on the Facebook group of the low water. There's some really classic pictures, people standing where they should be underwater and they're high and dry, really. And it's fantastic documentation for what happened, because multiple people who have lived in Nome their whole life and are older than me have said they have no memory of water as low as it was on the 12th. So it's an important event to gather that citizen science observations so that we have that record. And yes, we get, okay, 7.9 feet below the low tide line. That's great, but let's enhance that with what it actually looked like and keep that for future reference.
And actually for in Nome, there was, in front of Northwest Campus, there was a feature in that low water that we never see. And sometimes you think it's a marine mammal, because if we have a low tide, you may just see a little bit of slick. And that is if you drove past Northwest Campus during that low water event, and that was, how much water was out? 8 feet, 7 feet?
Yeah, just about 8 feet.
8 feet of water. So right out in front here was a big, did you see the big block structure? That is the old 1900 pulley system that they had for the barges, and they bring them in offshore right in front here and have a pulley system to this beach. And so that is a big navigational hazard, because it's gonna kill somebody sometime or rip off their lower unit. But that, if you saw that, that's something that has not been exposed like that. People were sending in pictures of shipwrecks from, I mean, it was really outstanding.
Yeah.
Water.
Yeah,
It
it
was
was
something.
really ship that went down decades ago
Yeah.
in front of Gullivan, appeared out of the water.
Yeah.
Really
So-
quite amazing.
And then to see that how many days did you say? We got the
So yeah, that's what, 11 days.
11 days difference. So now for those of you online, we've got in the room here, the Healy currently is about 15 miles. The US Coast Guard icebreaker Healy tonight is about 15 miles currently, southwest of Nome, and you should see them. What time are they picking you guys up? Tomorrow? Okay, so it'll be light enough, so if everyone, if you want to get a look at the Healy, they're not going to be coming to the dock for sure, but that'll be the ship that's out front in the morning. And they're taking this science party and heading back up. But I have a question for all these nice scientists that are sitting in the room here. When you see the water do that, pull down for 8 feet and whatever it is, however many days later, push back up to record levels, and we've had cold water, and we've had storm after storm, and we just rolled everything and have this terrible situation in the Chukchi and Scammon Bay, the water rose to Merbach levels or above Merbach levels.
That's what is on social media. Scammon Bay is south of here. So that's Scammon Bay, Chivac, Hooper Bay, that area there, kind of in the YK Delta divide there.
So with all that going on, and you guys are going on the Healy to do your science, yeah. So will we be able to hear back from you guys at any point later when you're all back later to refer back to this night and sort of learn what it is you're seeing on the Healy? Because so rare you're going north at this time of year after all this very unusual situation, and you're going to be looking at all your all that you do and your expertise that you do. I think wouldn't it be nice to hear what they
It's always nice to hear what people are
finding. I think that would be something to think about. I don't know how your chief scientist, I know you guys are on a training. This is a really great group of people. But if you can think about that and look, and I hope this was helpful for you guys to sort of, before you go, get this information, because you really stepped into, you just showed up here in Nome, and it's really been a lot going on. So thank you, Rick, for bringing it tonight, and just the timing worked out with these guys here and the ship arriving soon.
Yep.
So with that, any questions for Rick?
I have one general senior citizen comment. We started a skating rink out here in 2002. And we were usually playing hockey on the rink by sometimes Halloween. Normally always by the 1st of November. Now, about 10 or so years ago, maybe a lot longer. Now we were getting on the ice just before Thanksgiving. Now it's getting closer into December. And we've kept records since 2002 when we got the ice. So
The rink.
things a little bit shorter season for us, so to speak.
And that's fantastic information to have. Please keep recording that. Because that's, it's a nice it's a nice piece of information that we can add, that so we have all these, we have climate models, reanalysis models, we have observations, standard meteorological, climatological variables, but this kind of stuff just adds, I think, a real dose of reality to the changes that we're seeing. Think of, the lunatic way that the Nenana Ice Classic is run. No one in their right mind would ever devise, put a tripod on the ice and run a clock to it to measure breakup. But it's been that way for more than 100 years, and it's become this invaluable climate record. It's possibly the cleanest climate record we have in the state. So this kind of stuff is it sounds like, oh, what, who cares when the hockey rink is available? Well, people that want to play hockey care a lot, but we can use that for other purposes, like putting a face to warming falls.
We had a Halloween party on the ice for all the kids one year.
I'm gonna guess that's not this year.
Real hockey. No, not this year.
Question?
Oh, I did. Yeah, it has been really incredible to hear all this context. So thank you so much. Before we head out, I actually was curious if you kind of hinted at this when you were talking about it, but for this low water event, you hinted at that obviously the sea ice is anomalous in terms of having all that open water. Do you think that is really the primary driver of this, or do you have a sense from the context of the records and the reanalysis how much the wind was anomalous and contributing to that as well?
For driving this very low
Yeah.
water, I think the wind is almost everything.
Okay.
Even back in the day, there would not have been a lot of ice in the Bering Sea yet.
Right.
On the other hand, having screaming north winds from the Bering Strait to Dutch Harbor is not that unusual in the winter, in midwinter, when there is ice, at least in the northern Bering Sea. So the combo of two not unusual things, no ice in the Bering Sea, and these long fetch north winds came together, I think, in this. So individually, neither of them terribly unusual. Putting them together, and particularly getting that kind of long north wind fetch this early in the season, that I think was the driver. And I should say, it's definitely, this was not at a time of an unusually low astronomical tide at all. The astronomy did not play a role in this.
My question is, given all that big open water, which is going to have an impact ecologically for this region, likely, and impacting as well people's ability to maybe have their harvest seasons on, probably not on time, but hopefully so. But it looks like that's a lot of open water there. The water is colder. That's kind of what I saw, or it's a little bit cooler because of the ice and the storms and the mixing. Once the ice starts forming, do you think it will be in its favor to more quickly harden up or slush up?
So I'm going to guess we have some experts in the room on that. But here's my take on that. Actually, all this storminess, this well-mixed water that we had in the Bering Sea from the late summer storminess, this storm, obviously the storm that just went through, did a whole lot of mixing. What we've done now is at this late in the season, we're now mixing up warmer water from below. And so all of this storminess may actually slow down the development of sea ice compared to if it had been not as stormy, not as well mixed. We're probably at this point we're probably talking maybe a difference of a few days. But we are not starting as in a nice cold water right at the surface because it's been clear and calm and cold and starting to get that frazzle ice to form. That will happen. It's just going to take longer.
I mean, currently that's about almost 300 miles or 275 miles off from Utqiagvik to the ice edge.
Yeah, I mean that's 75 north right
Yeah.
there. I mean, we got some ice behind the barrier islands, and maybe it's starting to creep out now. But the pack ice is still very, very far away.
Um,
And here, the last sunset of the year is coming up here in 10 days here at 75 North.
Wes, I see your hand is back up.
Yeah, I was gonna follow up with a observation from what Rick commented there about us having sea ice taking longer. We've had, I want to say 3 or 4 years ago, maybe it might have been longer. We had a situation where Eastern Norton Sound had started to freeze up, and I mean was really solid on the freeze up. We had one of these big storms come in, and the water opened up, and then it was weeks, even though the air temperature dropped down, it was weeks before it refroze. And I think we're seeing kind of that in the lower river of the Unalakleet right now. We had started to freeze up. Yeah, it warmed up during the storm, but we're already down colder temperatures than we were seeing before the storm. And the river didn't even show any sign of starting to freeze up. And I'm not saying the estuary that was flooded. So that really seems that a lot of warm water moved into our estuary, at least from the ocean. So thank you.
Thanks for that observation, Wes. Really important. Appreciate it.
And I guess I'll just add, thank you, Wes. Rick Thoman wanted to see if there was, see the effects of the storm when he first got here. We went to Cape Nome and I got a water sample for harmful algal bloom monitoring. And the water temperature at Cape Nome on the 22nd was just the surface temperature. It was really roiled up. It was really mucky and big swells still at Cape Nome. And it was 38.1 Fahrenheit or 3.8 C, I think is how that works. And so, I don't know, but it seemed it's got to cool down quite a bit more, but maybe that'll come. I don't know what.
And that 3.8 C temperature was a little bit higher than what you had measured.
Before the storm, it was 3.4
before.
C. And after that, I was really curious to see if we were going to get a jump in water temp, and it seems like we kind of did after. So I'm just adding that. In the other thread, let Rick know that it's a great synthesis tying the Nenana Ice Classic in with the new hockey rink ice skates. So you should share that with Rick if you want. It's so interesting and stunning all at once. So thank you guys. Thank you, Mitch, for bringing that up, and the Nenana Ice Classic too. Any questions from out of Nome, online? Any other questions or questions in the room? All right. Well, good luck to those of you marining out of here tomorrow and heading into our storm-filled fall. Good luck with that. And I'll take it on land easily.
So I do want to thank Healy folks for coming, gave you something to do, and I also want to thank folks from the Capri workshop for taking time out of what's been a very busy week to come and join us. So go ahead up.
Thank you. And Sue, I just saw your post. Where are the photos people posted of the low water event? Actually, I think if you just go to Facebook and type in Nome, you might see quite a bit of the low water event pictures. All right, with that, thank you guys so much for coming, and we hope you come back, Rick. I mean, honestly, that is heartfelt that you, if you live here, I know you guys are all visiting and there's people online that do live here. If you've been living here for your life or for the last 20, 30 years, 10 years, it is a wild ride that we don't get to have someone with us that is there that understands this region and the place names and how things work and have actually been here. And so I just can't reiterate enough, Rick. You are like you're kind of a part of the group on this wild ride through the Bering Strait region with what's been going on, and it's something to behold. So we are grateful, and we hope you come back and do another Straight Science and tell us what the spring will hold. Honestly, All right, with that, thank you all so much, and I'll turn off the recording. Thank you, everybody online. We'll see you next, let's see, wait a minute now. The next Great Science will be November 7th, and it'll be talking about wave exposure on the coastline here in the Bering Strait region, so it ought to be pretty appropriate, and you'll be getting those notifications soon. Thank you so much.